Alright, welcome to tonight's video. We're going to be doing a couple more equation questions, and then we're going to throw in a new one about inequalities. So let's get started. Let's go with something pretty simple, straightforward. Let's go with 0.4 plus negative 7x. And that's going to be equal to 15. Same thing as usual, what's happening to the x right now? It's being multiplied by negative 7, and it's being added by 0.4. So everything's about opposite still. So subtract 0.4, subtract 0.4. Alright, this goes away basically, and I'm left with negative 7x, and that's going to be equal to, how do I subtract this? Do I do it like that? Right there? No. What about that right there? Yes. Put the 4, put the 10, 6, 4, 1. So 14.6. Right, now what do I do? What's happening to the x? The x being multiplied by negative 7, so I got to divide by negative 7. I do it on both sides, leaving x by itself. Alright, so now I got to start doing what? I got to do this little division problem, right? So negative 7 here and 14.6 here. Does this negative really matter? I don't need it in my division problem. What I need to remember is that if I'm dividing a positive and a negative answer, if I'm dividing a positive number and a negative number, my answer is guaranteed to be negative. So I can be done with that negative sign. I don't have to mess with it anymore. Of course, 7 does not go into 1. 7 does go into 14 twice. Subtract and get a 0. Drop to 6. Bring my decimal up. Doesn't fit into 6. Put the 0. Drop it down. 7 goes into 60. 7 times, or 8 times, 8 times, 56. Subtract to get a 4, drop the 0, 7 goes in there. 5 times, 35. Subtract to get a 5, and I'm going to stop right there. Why am I stopping right there? Alright. For the most part, it's because Mr. Darden has been telling you all year to stop on the third number. So we're going to stay true to that. Okay? We're just going to stop there just because. So 2.085. And I'll put a little dot right there to indicate that I'm not really done with the problem. We're just focusing on the fact that because I had addition, I subtracted, and because I had multiplication right here, I divided. Reminding myself that if I have a positive and a negative, then I get a negative answer. Alright, we're going to skip the next inequality, and we're going to go, the next equation, and we're going to go straight into the inequality that I'm going to be talking to you about. Alright, now, the inequality that I'm going to be talking to you about is very similar to the equation. The difference is it's going to have a little bit of a different symbol in it. So let's just get right into this. Let's go with 7x minus 18 is less than or equal to 32. Now, equations have equal signs. Inequalities have less than or greater than types of symbols. You got 4 different inequality symbols. Okay? You've got the less than. You've got the greater than. Excuse me, just spelled that wrong. Greater than, the less than or equal to, and then the greater than or equal to. Which one of these symbols is right here? It's correct. The less than or equal to. Alright? Now, here's the best part about this. Inequalities and equations all work the exact same way. So we're just going to do the opposite again. Add 18, add 18. This goes away, left me with 7x is less than or equal to, what, 50? Because that's 10, carry the 1, get 5. Divide by 7 because that's the opposite of multiplication. Got to do it on both sides. Leaves me with x is less than or equal to negative 1. Excuse me, less than or equal to whatever the answer to this division problem is. So put my 50, put my 7. Of course 7 doesn't fit into 50. 7 goes into 50 7 times. It's 49, subtract and get a 1. Do I stop? No. Put my decimal, 0, 0, fits in there once, subtracts and get a 3, fits in, got to drop another 0, fits inside there 4 times, gets me a 28. Alright, drop another 0, fits in there twice. And once again I'm going to stop because it's the third number behind the decimal. Alright, now remember, inequalities and equations solve the same way. It's all about opposites.